Hello viewers, Alan here again. In the last few videos I've been getting ready to cut notches in this index ring as an attachment for a dividing head. So I had to grind a cutter specially to do it, and then I had to fool around getting the milling machine set up at the right height and everything. But today we're ready to go, and in this video we're actually going to cut the notches. So let's get into it. Okay, so I'm getting ready to use this cutter properly and to face up to another little issue. The keyway in here is, well, the keyway for a 1-inch shaft is typically 1/4 inch. This is a spacer off my arbor, and 1/4 inch bit of key stock. But as you can see, it's not interested in fitting there. Instead of being 1/4 inch, which is what, 6.25, something like that millimeters, it's actually 5.02. So I don't want to have any trouble with the milling cutter slipping. We've got quite a few slots to cut with it, so I'll have to make up a special key which is 1/4 inch on one side and 5.02 on the other. So that's the next little job. That was at 1.6, now we've got to come down to 3.2. Okay, well here's the key narrowed down on both sides. So we've got 6.4 or 1/4 inch on this side, 6.35 I guess within range, and I was aiming at 5.02 for here, and I think I'll take that, it's close enough. It isn't going to make any difference. So I guess the next thing now is to see whether the key actually fits. Let's go over to the milling machine and see. Okay, so this cut is actually a fairly tight fit on the arbor, but anyway, so here's our slimmed down key. Yeah, that's going to do just fine. So these other pieces, of course, happily fit on because they're designed to fit on the 1/4 inch key. So I think that's going to work out just fine as far as anchoring this thing on this arbor. Okay, so this guy here weighs 47 kilograms, so not to be played around with, especially when it's up at this sort of a height. So I've got a little lifting eye bolted onto it here. We should be able to lift it up and lay it over on its side without too much stress and drama. So changing central gravity is quite a challenge. Try and make sure I don't get underneath it as well. I think we've got it under control now. The lifting eye is only clamped on, so I'll treat that with caution as well. But it seems to be working all right. Right, and that's achieved that under control and safely with no injuries. Right, let's get it lined up on the milling table. Okay, so I've got the index ring mounted on the 3-jaw chuck using the internal jaws. I'm using my other dividing head, obviously. Now I put them on the internal jaws so I would have clear access around the outside, both sides. So I've centered it in the X coordinate by measuring from the sides of the arbor out to here using a square and rule, and it's only approximate, but it doesn't need to be accurate because of course the thing will be run backwards and forwards to do the cutting. But the reason I wanted to get it roughly centered is so that I could get a reading from the side of the cutter disc to this outer face here, and I set the cutter face to be, using a feeler gauge, 20 thousandths of an inch clear of the side, zeroed the DRO at that, came over and repeated the exercise on this side, and then used the DRO function to divide and set the centre in the Y direction. And it's the centering on the Y coordinate which is important, because I'll be running the disc backwards and forwards under the cutter. So hopefully that all makes sense. The next step is to mount the indexing wheels on the dividing head so I can do the 60 divisions around for my notches that I've got to cut. And I'll be cutting across the full diameter of the ring, so even though I want 60 notches, I'll only actually have to make 30 translations with the cutter. So that's the plan. I'll get the rings on, the indexing rings on now. I referred to this beast earlier as a dividing head. Well, it isn't really, it's actually a rotary table, but I've got an accessory for it which allows it to act like a dividing head. So to do that, I have to take this piece off and whatever. But before I do, I'll just mention the way it's set up by default is there's a degree ring on the back of the dial here, and an index set of index marks here, and so you can mark off degrees and seconds. So it would be possible to do 60 6-degree increment rotations and I'd get the result. But that's a bit of a fag. It's easier to use the dividing head function with the index wheels, so that's what we'll do. I'll show you how we set that up. So we have to take this piece off. Careful not to lose anything. So that comes off. I'll put you down there for a moment. And this piece also has to come off. It's normally held secure by a grub screw there. Take that off. Okay, so I'll put the division plate on now. To get my 56 divisions for one side of this ring, I need to use a ring that's got 26 holes in it, and for the other one I need to either do 32 or 30. To get 60 divisions, I either need 32 or 34. So that's from reading a chart that came with the rotary table, but the practical reality is that to get 60 divisions there are many choices. So let's get this on. So I'm putting this ring on with the index numbers here so they're easy to read, and or at least easy for me to read. You might not be able to see them. Alright, so we'll just tighten these up a little bit. They need to be nipped up. There's no reason to go bonkers with them. Just got to hold the plate on, that's all. Stop it moving around. Alright, so that'll be tight enough. So that's that. So the next bit is to put the pointer fingers on. And that's flopping around, as you can see. So the design allows or recognises that, and they get this special spring that will tension them. And a lock ring which can be used to set the preload on that spring. And we'll put him on. I think that's just gently nip that. That's good enough, right? And you can see, oh, now we put the pointer on. And I've set, oh, this is a modification. When you're doing this sort of stuff, it's handy to be able to hold the spring-loaded plunger out the way. So I made this spring up to hold that out the way. It's useful sometimes it gets in the way. Anyway, so we want to be pointing at, well, we're going to do the 60 divisions first, which means we want to point at 32 or 34. Actually, I think any even number over 30 would work for getting 60 divisions from a 1 to 90 gear ratio, and I've chosen to use a 44, as you'll see. Back. Alright, putting that on. Okay, so the dividing head's set up with the division plate on. To do a very quick overview of how this works. The rotary table has a 90 to 1 gear ratio between the worm, which is on this axis, and the worm wheel, which is the table is bolted to. So in other words, one rotation of this and the connected worm will turn the table 1/90th of a turn. So we need to get 60 divisions, or turn it 1/60th of a turn at a go. So that means, quite simply, we have to turn the worm 1.5 times, and then we'll get a 60th of a revolution here. It's that simple. So to do that, we can basically pick any even number and do 1.5 turns. So the larger the number, or at least the further you're away from the middle, the easier it is to control it. So I'm on 44 to get 6 degrees. In fact, before I do that, just show you there's nothing up my sleeve. Perhaps you can see down here that it's showing 0 degrees. I don't know how well you'll be able to read that. We'll see when I play it back. And I'm going to do 1.5 turns. So I pull this out and get my own way here. It's 1.5, and if we go back and look at the division here, we should see, hopefully you can see, that that's now on 6 degrees. So it's basically as simple as that. There's no black magic involved. Because of the gear ratio here, we have to turn the worm, which is attached to this, 1.5 times to get a 60th of a revolution of the thing. So once we've done one, we swing that around, just as a convenient placeholder. 1.5, back up to there. If we go and check again, we'll see we're on 12 degrees. Well, again, hopefully you can see that. So that's how the dividing head works. 60 divisions is easy to get because it's a 1.5 sort of a multiplier for the gear ratio. Okay, so as you see, I decided to use the outside jaws instead of the gripping it from the inside. I think it's just going to have a much better grip on the ring. Plus, I was happier to wind the chuck jaws up tight against the outside of the ring rather than squeezing it from the inside. They're still low enough. I'm going to cut down 3mm, and you can see I've got far more than 3mm there, so I don't have to worry about the tops of the jaws getting in the way. but I was really worried that the cutter would start developing uplift and try and lift the workpiece out of the chuck jaws. So I think now the idea is going to be to do a couple of test cuts, just touch off basically. So touch here and then touch there and rotate 180 degrees and see whether the marks line up, and that'll tell me whether I've really got this centered or not. So that's the next move. Now I don't know how well you're going to be able to see this, but I have done a slight touch off here with the cutter, and on the other side of the ring here I've made a couple of scratch marks, which perhaps you can see, just using a centering ruler, working from each side of the touch off mark, the other side of the touch off mark, and this has created a pair of marks here. So now when I turn the disc around 180 degrees, I should be able to see how well the cutter lines up with those pair of marks, and that's how I'm going to validate that I've got the disc centered under the milling cutter. Okay, so we'll turn this round 180 degrees and see how the marks line up with the cutter. We'll come back over to let's see if we can ever get some light on and see how they line up. Had a lot of trouble getting a picture of this, but if you look really closely you can probably see that in fact both of the marks line up on the sides of the cutter. And in this picture you can see that the cutter did in fact touch off exactly between the two lines. Alright, so time to start doing some cutting. We'll see how this goes. A little bit of oil there. And I think we're pretty much through on the first side. We'll stop the feed. Right, a bit of oil on this side. Alright, well that's done the first two for the first full cut, so I'll just wind this back and have a proper inspection. Well, we've definitely got a groove. We've got two grooves, I suppose you'd say. Pretty happy with that. That's going to work out just fine. Yep. 29 more of those. So we go to our 1.5. There's one. And round to the half, making sure we don't overshoot. Right, and we should be good to go for the next one. So I'm getting into the swing of it now, a bit of a rhythm, and we're on cutting groove 7 I think this time. Making it, well, slow but steady progress. Halfway mark and the cutter seems to be holding up just fine. Now's when I get to find out whether I've got it right or not. It's taken me over an hour to do that last lot of 14, but we're on hopefully on the last groove, and it's going to turn out to be in the right place. Fingers crossed. Well, there we have it. Looks like all the calculations were right, and we've got a 60 notched index ring wheel. So time for a big clean up. Oh, I did that up pretty darn tight. Well, time to clean it up and have a proper look. Okay, so this is the finished item, all cleaned up. I think it turned out looking pretty good. Although what it looks like isn't maybe so important. But anyway, the teeth came out looking pretty crisp and clear, and I got the right number of them. So I guess that's the best I could hope for. So I'll go and put it on the machine and see it in operation. Okay, let's get this guy on there and see it working. So I've fitted this business in here, so you can see how that's supposed to work. There's a spring there, of course, so just put him back out of the way. Slip this on. It's a pretty close fit. Come on, get on there. Right. Right. So I've got to cut the teeth on this side yet, but I'll do that separately off camera. And I think you've seen enough of cutting teeth. And for now I've done enough of cutting teeth, I can tell you. Right. Move you around for a better look. I think it's a bit better. So we can pull this out of the way. So this is still a bit stiff to move by hand, and I've got to find out what I need to free up to make that easier to move. But we can see anyway, so that's a spring-loaded plunger working for us. If I re-engage this, alright, so If I turn that, so it's just done what we need it to do. So that all works fine. So I just need to be able to attach a chuck to do some useful work to it now. I mean, one way I can do that is with an NT40 adapter for an ER40 collet chuck. I've got all of that, so that's one way to go. But I'm going to make a chuck backing plate to mount on these 4 holes to locate on this outer diameter here as a, what do you call it? Well, anyway, a locating radius, and yeah, bolt up, but that's for another project. Okay, so that's going to do it for this video. It's been going on long enough, and I want to have a bit of a break and do something else. It takes a lot of time doing the filming for this sort of detailed machining, different camera angles and the like, and a lot of concentration too, so you don't mess the job up and cut your fingers off or anything nasty like that. But anyway, hope you enjoyed it, and please like it if you did. Subscribe maybe if you haven't, and thanks for watching.